Hello everyone, how's it going? My name is Dan the Tutor, on a mission to become the world's greatest tutor. Today we're going to be talking about center of mass in two dimensions. That's right, the x and the y dimension. So first I guess I should give you the center of mass equation. So x center of mass is simply fraction bar. In the numerator, mass 1 times x1, which is some x distance, plus mass 2 times x2, plus dot 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 for however many masses you have. And then in the denominator, it's mass 1 plus mass 2 plus dot 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 however many masses you have. So hopefully you see the pattern here. We're going to do some examples with this. And also for the y center of mass, it's literally the exact same thing, except you replace the x's with y's. And so it's a common theme in physics is that we break x and y into different components. And yes, we'll be doing that today as well. Not using SOHCAHTOA, but just, I guess, common sense, as you will soon find out. So let's say for our first example, I have a coordinate grid with 3 points on it. First, I have a 2 kilogram mass, which is at the coordinate point -5, -1. Remember that's x, y. Nudge, nudge, wink, wink. Over here, I have a 3 kilogram mass, which is at the coordinate point 4, 2. And then the last one I have is a third mass down here at 5 kilograms. It's a big one. And the coordinate point is 3, -2. And I want to find the center of mass of this system. And so all I got to do is use the center of mass formula twice, once for the x values, once for the y values, and we'll be good to go. So in other words, x center of mass equals fraction bar. Mass 1, which I'll say is the 2, times its x distance. The x distance is the -5, so 2 times -5. Plus mass 2, which I'll say is the 3. 3 times the x distance, which is 4, so 3 times 4. Plus the last mass, which is 5, times its x value, which is 3, so times 3. And then divided by the sum of the masses, 2 plus 3 plus 5, like that. And then you just plug this in a calculator, and I'll get a value of 1.7. No real units here because I didn't give any, but this is the x value of my center of mass. Now I got to do the same thing, but with the y values. So for the y values of center of mass, then it's going to be mass 1, which is the 2, times its y value, which is -1, plus mass 2, which is 3, times its y value, which was 2, and then plus the 5 kilogram mass times its y value, which was -2. And this is all over the same sum of masses as before, 2 plus 3 plus 5. And then you just plug this in a calculator, and you will get -0.6, and that's the y value. So in other words, if the whole coordinate point then is 1.7 for x, which I shouldn't write x in the coordinate point, just 1.7, comma, -0.6, then this is the coordinate of my center of mass. So in other words, if I were to plot that back on the graph, 1.7, -0.6, that's like somewhere probably over here where my blue dot is. And if I just look at my points, it kind of looks roughly like that should be the center of mass. So that's a good way to quickly check my answer to see I didn't make any stupid mistakes. So that's good for that one. Now we just got one more today. For this one, it's going to be similar but different. I'm going to give you 2 coordinate points. This one here, which is 16 kilograms at the coordinate point 4, 3. I'm then going to give you this coordinate point down here, which is at 4, -5, and this mass is 20 kilograms. And you're going to tell me where to put a third mass, which has a mass of, let's say, 24 kilograms. And you're going to choose the third mass, where to put it, both the x and the y value, so that we can get a center of mass at the origin 0, 0. So in other words, you are solving for the x and the y value of this third mass. Now, if you are physics inclined, I guess, you would know that the third mass needs to be somewhere over here. And if you don't know that, it doesn't really matter. We're going to prove it anyway. But if your initial guess was somewhere in this general area to balance out the other 2 dots, then you would be correct. But if I actually want to solve it, here's what I would do. X center of mass equals fraction bar. Mass 1 is 16 times its x distance 4, plus mass 2, which was the 20, times the same x value 4, plus the 24 kilogram mass that I'm adding times its x value, which I'll just be calling x, and then divide it by the sum of masses, 16 plus 20 plus 24. And like we said, we want this center of mass to equal 0, so that's exactly what I'm going to do. I'm going to set this equal to 0. So then simplifying this as much as I can, the numerator is going to be 64 plus 80 plus 24x, and the denominator is going to be 16 plus 20 plus 24, which is 60. And then I can multiply both sides by 60, but it doesn't matter since anything times 0 will be 0, but 0 times 60, getting rid of the denominator, equals 64 plus 80 plus 24x. So 0 times 60 is 0. 64 plus 80 is 144 plus 24x. So now I just subtract the 144 to the other side and then divide both sides by 24. And that'll get me the x value of the center of mass, which is exactly -6, a nice round number. So that's the x coordinate. I still got to find the y coordinate. And to do that, all I got to do is y center of mass equals 0. And it's also equal to mass 1, which was 16 times that y value is 3, plus the second mass, 20, times its y value, -5, plus the third mass, which is 24, times its y value, which I'm just calling y, and I'm solving for y. And then that's divided by the same sum of masses, 16 plus 20 plus 24, which will be 60. So then 0 equals 16 times 3 is 48, minus 100 plus 24y divided by 60. Then I just multiply both sides by 60. So 0 equals 48 minus 100 is -52 plus 24y. Add the 52 to both sides equals 24y. And then divide by 24. And we'll get y equals positive 2.2. So in other words, the final coordinate point, you could say, is -6, 2.2 for the x, y. And I would accept the answer written like this, or if you just wrote out x equals -6 and y equals 2.2, that's fine as well. And so I guess finally, just showing you what that would look like on the original graph, -6, 2.2 is somewhere like around here, which is basically what I said from the beginning. Maybe it's a little further to the left. Maybe it's like this. But that will get me a center of mass of 0 of the 3-mass coordinate system. And so if you have any more questions with that, please leave a comment below. Thank you all for watching. I hope you have a great rest of your day, and I'll see you in the next video. Take care, and bye-bye.